Hey programmers, Alvin here. Right now I want to go over a Python solution for this bottom right value problem. So I'll jump right in and we just want to implement the exact strategy we spoke about in the approach video, right? Which means we're going to do a breadth first. And so I'll go ahead and set up the boilerplate for that. By now you should be very familiar. I'm going to use a queue, so I'll say from collections import deck. Because if I use just a plain old list to implement my queue, it's going to be pretty slow when it comes to removing from the front of my queue. So since it's easily available in Python, I'll go ahead and use the deck, which offers O of 1 addition and removal from either end of the collection, right? I do have the assumption here that my tree is non-empty, so I can just jump right in and initialize my queue to be a deck containing just the root. Nice. And then from there, I need my main loop to actually run this algorithm, right? So while my queue is not empty, do some stuff, right? So I'm just laying out our basic breadth first. Just remove the front of your queue, so I can say current equals queue.pop left, right? That's a method I could use on a deck. And from there, I want to look at the children, right? So if the children exist, so I'll say if current.left is not none, then they exist, so I should add them to the queue. So queue.append current.left. And then just symmetric for the right child. So if your right child exists, then put them in as well. Nice. And so at this point, I'm doing a breadth first traversal, so it's going to go level by level. And what I'm hoping is on the very last iteration of the while loop, I should have just removed from the front of my queue the rightmost node. So it's important that not only do I have a breadth first, but this breadth first travels from left to right. And that's going to be true based on how I have it implemented right now because I push left before right. So that means the last thing that will leave must be the rightmost node of the bottom level. Just doing breadth first alone gives you kind of levels at a time. And so one thing I can do here, although it's kind of not my favorite thing to do stylistically, technically once the while loop is over, I just want to return the last value of current, which maybe you know, maybe you don't for my Pythonistas, but you could actually return current over here, which may or may not seem suspicious to you. For me, it's kind of suspicious and uncomfortable, but we'll just run it and then I'll kind of talk about why that is, maybe riff on some Python scoping stuff. So if we give that a run, oh, I have an error here. So expected 1, I gave back an instance of node because I want to return just the value, right? So try that instead, give that a go. And yeah, this should totally pass, right? So something that I'm leveraging here is just how Python scoping works. So this variable current, although it's like, I guess, declared or initialized within the while loop, it is technically accessible after the while loop runs as well. So I could print out current over here, right? Which I don't think is something you should, I don't think, do too often in Python, because I don't think a lot of people know that behavior. So maybe just to make things clear, and whenever I'm in a situation like that, I would actually initialize current as none up here. It just makes it more obvious that now I have a current accessible not only within the while loop, but also outside of it, which is kind of consistent with other programming languages like, I don't know, JavaScript, that have more of a block scope for their variables. But this will work all the same. If that doesn't tickle you fancy, something else you could have also done is maybe just explicitly check. You know that your algorithm's over when your queue is empty. You could have also just did an early return, I guess. So something like this. So like if your queue, we'll say if the length of the queue is 0, so equals 0, then you can also just return current. And now this code is inside of the while loop, right? Because let's say that I just remove something from the front of my queue and I add any of its children. If it has no children and there is absolutely nothing on my queue, you're at the end of your algorithm, right? And you're done with your traversal. So this should work as well. But any way you slice it and dice it, got to be sure to return val, keep doing that. Either way you slice it and dice it, you do want to, I think, solve this one with a breadth first traversal. I think it's the easiest way to write it. Almost no nuance here at all, just returning the last value that you iterate over. Cool, so with that, practice this problem and I'll catch you in the next one.